Let's start. So we are going to start CCNA. Okay, this is the code for the paper 200-301. And first we look at the syllabus. These are the topics we are going to cover during our course. Okay, introduction to networking, Ethernet LANs, VLANs, STP, IP for addressing routing. This is a protocol called OSPF, IPv6, wireless. Okay, these are the topics covered in first book, volume 1. In volume 2, we have security related topics like IP access control list, security services, IP services, network architecture, and automation. Okay, these are the topics we are going to cover. Maybe not in this order. Okay, the order which I'm going to use will be, first I'm going to start with IP addressing, because for testing we need address, right? Or for testing we need address on every device. So first we'll start with basics. Okay, then IPv4 addressing. Okay. After that I will go for introduction to routers. Okay, then we'll come back to TCP/IP model. If I start with TCP/IP model in the first class itself, we will not be able to see practically how it works. Okay, so at least you'll do a little bit about routers, how to assign IP address, IP addressing, and then we look at the TCP/IP model. Once this is done, we'll move to the routing part. In routing, we are going to cover static routing, whatever there in the syllabus, static and default routing, floating static route, all those things what are in the syllabus. Then we'll go for dynamic routing. In dynamic routing in the syllabus, we have only OSPF, but we'll take one day for RIP and EIGRP. Both topics will covered in one day, so that you'll know the difference between the different routing protocols. Okay, OSPF will be part of the syllabus. We are going to do this in detail. Okay, then we'll move to the switching part. Next topics will be switching. Whatever switching, complete switching we are going to do. After switching, we'll go for wireless. After wireless, we'll have IPv6. Okay, IPv6 and then IP services. Okay, and other topics which whatever remaining. Okay, this is my plan. Okay, any questions, anyone?
Yeah, hi Shak, I'm back.
Yeah,
sorry, Shak.
no problem.
I believe you heard, somebody, mischievously actually sent around 60 schools some email that bombs
No
have been
problem.
planted, in their schools and all. So, I mean, we became frightened. I mean, that's why I
No
became
problem.
actually, I had
If you
joined,
want to
but
leave, you can leave the class
no,
for
no,
today.
no, no. I mean, I received the message that,
Box
actually
call maybe.
students are being sent through bus. So as of now, I'm okay.
No
So
problem.
no problem, we can continue. Ishak,
Okay.
perhaps you would have already, advised in the beginning. So I understand this is the plan you are sharing right now.
Yeah, yeah.
So how long, I mean, you think like it will take until I think 10th of June, you think around 40 days, you
Yeah,
think
yeah. 30
6
to 40
weeks,
because yeah, it will be 30 to
6
40.
weeks
The
around
10th
6
June,
weeks.
yeah,
Okay.
yeah. Okay.
Okay. That's okay. So you will be sharing, Ishak, some books and
Yeah, books,
all
yes,
those
yes. I'm
materials?
going to share a lot of books, materials, books. Apart from this book, there are, I have folder in my Google Drive. I'm going to share that folder. Also, the
Okay.
images which we are going to use for packet tracer and GNS.
Okay.
Okay. I'll show how to install also.
Okay.
Okay.
Thank you, Ishak.
Welcome. All right. So we'll start. About myself, I am okay. I'm CCI data center. I did my CCI in 2015, and since 2014 or 15, I'm in training. Before that, I was in Oracle also. I was a Oracle certified professional also. I worked in programming also for almost 10 years.
Great.
Okay, so my IT career you can see is from 2001 onwards. Since 2001, I'm in IT. Okay, my education background is I'm in CA. Okay, after that I joined Oracle. Then I went to Saudi Arabia where I have worked in HSBC, Private Bank, and other Deutsche Bank, other financial institutions. Then I
Okay.
come back and join again networking world. Okay. and I did CCI data center in 2014 or 15, and these are the other certifications I have related to network. Okay.
Yeah, great.
Right. So let us start. To begin with, we'll start with very basic. What is a network? Okay. See, all these materials, whatever we are going to see is from Cisco. These are authorized material. Okay. Earlier we were a Cisco partner, so we have those materials too. Okay. So you can see here the definition about network: group of two or more computers connected to share information and resources. Not only computers, you can call any device. Group of two or more devices connected to share information and resources. This is the definition for a network. Okay, practically we'll see. For example, let's say, see, this is called Packet Tracer, is a free download. So I'm going to share this for our labs. We can use Packet Tracer, and for advanced labs, okay, we'll use GNS. Okay, and GNS has the real software version of routers and switches. So any lab which requires GNS, I'm going to use GNS. Okay. For beginning, to begin with, we'll start with Packet Tracer. So you can see here we have some end devices. So I'll take two pieces, for example. See, these are standalone pieces. They are not connected to any network. If you are not connecting any device to internet or any network, they are standalone. Then with those devices, you can only access whatever you have saved in your hard drive, right? So they are standalone. If you connect these devices, for example, I'll take a cable and connect these two PCs or laptops, any two devices, then it becomes a small network. Okay, this is called a network with two or minimum two devices. Okay, with minimum two devices, you can build a network. Okay, see, if you have two devices, you can take a cable and connect, right? But what if you have more than two devices? How do you make them connect? Okay, let's say you have more devices, not two devices this time. You have more than two devices, like you have a server, you have a laptop, you have a printer. Okay, all these are called end user devices. Now, how do you connect this? Okay, because you can have only one cable per device, right? So how do you connect these devices? Okay,
With the
this is
help of
where,
a switch.
yeah, this is where we have two types of devices. Okay, networking, we have two types of devices. One is end user devices, the other one is network devices. Okay, what are end user devices? Those devices that provide services directly to the user, like computers, printers, scanners. They are called end user devices. Okay, these devices directly give services to the user. The other category is network devices. Okay, this includes all the devices that connect the end user devices together to allow them to communicate. So you can see in our networking world, we have two types of devices, end devices. Like these are the category of end devices: PC, laptop, server, printer, IP phone, okay, phone, TV, tablet, smartphones, okay, and other devices like sniffers. Okay, okay, these are the end user devices. The second category is network devices that includes routers. Okay, this is an example of a router. Switches. In switches, we have two categories: layer 2 and multi-layer switches. Then we have firewalls, security devices. We have wireless devices like access point, WLC, wireless LAN controllers. Okay, so these are the different network devices. Okay, so here to connect all these devices, we need a switch. Okay, to build our network, we need a device called switch. See, we have different types of network devices. I'll just give a brief about these devices. Detail we'll see as we progress. See, this is a router. Router is a device that makes communication between different networks. Whenever you want to make different network communicate, remember, different networks means router. The device that is used to make communication between different networks is router. If you want to build a network, same network, or build a LAN, you need a device called switch. Okay, so here I'll use switch and connect all these end user devices to the switch. Like I can connect PC, IP phone, printer, servers, okay, hierarchy servers. All these end devices are connected to the switch, one or more switches. Okay, this is called, this network diagram or this is called local area network or LAN. Okay, see here we have wired LAN. All the devices are connected with wired. Okay, but in today's network we have wireless devices also, like access point. So I can connect one access point to the switch here to the LAN. Now our LAN is called wired and wireless LAN. Okay. Now these devices can communicate. All these devices can communicate among themselves. Like PC1 can talk to PC0 or any device. I can take print. Okay. So this is now a full mesh topology. Full mesh means every device can directly communicate with every other device. Okay. Full mesh means every device can directly talk to the other device, every other device. But now to access outside world, a different network, I need another kind of device called router. So I'll take a router here. One of the interface of the router will be connected to the LAN, to the switch, and this is called gateway. The interface of router that connects to the switch is called gateway. And router will be connected to either outside world like a cloud or some other network internally also. Okay, suppose you are connecting to internet ISP or private WAN like MPLS. Okay, so one of the connection can be outside, or even within your company you can have another department, another building where you can connect. Okay, let's say this is another, I don't have number of ports here. Okay, leave it for timing. I'll leave it. Okay, this switch has only 2 ports. Okay, so this is called wide area network. Okay, the complete topology is called wide area network. Okay, you are connecting 2 or more LANs, 2 or more, like your head office, you are connecting to your branch office or site 1 to site 2 and so on. Okay, this is called wide area network. Okay, this is an example of a local area network where you have a switch. Okay, earlier there was a device called hubs which are not used in today's world. Okay, all the devices are end user devices are connected to one or more switches. Okay, and then you have a router which connects you to the outside world. Okay, and this is an example of a network device switch, and this are called interfaces or ports. Okay, in each interface or port you can connect one device. That device can be in device or it can be a router, it can be a switch. Okay, any kind of device, network device or end user device can be connected to every port of a switch. Okay, this is the device used to build your network. Okay, the number of interfaces or ports of a switch depends upon the model. Okay, it differs from model to model, but the functionality, the commands are same, whether you use 24 port switch or this is I think 48 port switch or any number of port. Okay, the only difference is in throughput, the amount of throughput you are getting. Throughput means the sum of the data you are sending and receiving. Okay, but the functionality, the command which we are going to learn is same. Okay. And this is an example of a router. Okay, you can see here router is connecting 2 different networks. Okay, if you look here, there are some numbers here. Okay, they are different. Okay, so router is a device that makes communication between different networks, and this is how a router looks like. This is one of the example of a router, and this is the representation of a router. Router switches, firewalls, all of them are usually flat, so they appear almost similar. Okay, is this clear? Any questions as of now? Anyone?
So Ishak, just one thing here to clarify regarding LAN and WAN. So whenever we are actually, I mean, multiple devices, as you gave the example of the mesh network,
Yeah.
and these are all connected through a switch only, and they are communicating within each other, like via switch. So this
Yeah.
is the example of LAN. and the WAN is like when two different networks are getting connected via router.
Yes,
So
yes.
because earlier, we used to hear like a wide area network means like the network which is spread across cities and
Yes,
very
yes, yes,
very.
of course.
So,
See here.
but in case, for example, we are expanding the LAN. I mean, for a longer area or for a larger area.
Yeah,
So the technically, if technically, I
yeah,
mean, area is the factor to distinguish between LAN and WAN, or the network or the presence of a router and the two
yeah.
different networks is actually the parameter which is identifying a LAN or WAN.
So when usually you can see area, usually when it was started, it was area. Okay, but
Okay.
now even the lands are extending to some kilometers. Like we have now fiber optic, which can extend your land to 30 kilometers also.
Yeah.
Okay, because of that, you cannot say that WAN same. It is within your same area. Okay, but still you are using routers. Okay, so you can say here, for example, suppose you have one site in same location. Let's say, okay, in same, for example, Bangalore,
Hmm.
and your other location is 30 kilometers away or 40 kilometers away, then still you can call it WAN. The term
Okay.
used is WAN only, right? We don't have any other alternative term. There are
Okay.
terms like Metro Ethernet. There is a, there is a WAN service called Metro Ethernet, which is within your city limits.
Okay. Still, it is WAN.
WAN only, yes. Okay.
Okay. So even the LAN is spreading across 30, 40 kilometers.
Yes, yes.
It will be called as WAN, huh?
No, no. See, it depends. If you are using a router,
Uh-huh.
okay, then WAN comes. If it is, see, there are some which you are going to learn later on. There are some connections like L2 connections. It's still called WAN only. Okay, but say, like
Okay.
suppose you have a building or you have a university, okay, covering few kilometers.
Hmm.
Okay, that you cannot call WAN. This is within a company's network,
Okay.
right?
Campus within campus.
Campus network, yes, campus enterprise network. Okay, so WAN
Hmm.
means you are, maybe the best term still you can say two different locations, geographical
Okay.
location.
Geographical location. Okay.
Okay,
Got it.
right. Okay. Okay, about Cisco, leading manufacturer of the networking devices. Okay, these are the devices that Cisco manufactures: switches, routers, firewalls, voice devices, data center devices, and wireless devices. Okay. Now coming to the main topic here. Now this is where our actual main topic starts. What is TCP/IP? See here in our network there are devices from different vendors, right? Like suppose this is Cisco router. We have a, for example, switch from Juniper, other vendor. Okay, we have devices from IBM, HP, servers from HP, IBM. Many vendors are there, right? How do devices from different vendors communicate? Right? How do devices from different vendors communicate? This was not possible in 1980s when the network was started. In 1980s, there was a big problem. Inter-vendor communication was not possible when the network was started in early stages in 1980s. You can see here there were big companies like IBM, Digital Equipments, and other vendors. They have their own networking model. Like IBM has a model called SNA. Okay, IBM has a model called SNA, Systems Network Architecture. Okay, this works only on IBM devices. Similarly, other vendors have their own proprietary networking models that work for that vendor only. So, if suppose you are engineer, you have brought up devices from different vendors, it was difficult to connect them. Okay, so as a engineer, you have to get devices from same vendor to build a network because inter-vendor communication was not possible in 1980s. Okay, so in 1990s, TCP/IP was introduced. Okay, TCP/IP is a networking model which contains a suite of protocols. Okay, which defines each and every function required for a network. So initially, when it was started in 1990, okay, it was used to make communication between two different devices from different vendors. But by year 2000, the industry felt the benefits of TCP/IP, very robust protocol with lot of good features. Everybody started using TCP/IP. Okay, and this is the model around which today's internet is built. Okay, Now inter as well as intra vendor communication, both we are using TCP/IP. Okay. Okay. TCP/IP is a standard protocol. Standard means, see, there are two types of protocols. Protocols means set of rules. One is standard, other one is proprietary. Standard means multi-vendor support. Okay. Proprietary means for a specific vendor. Okay. So TCP/IP is a standard protocol, or you can say networking model, used between computer and network devices for communication. Okay. And the first part in TCP/IP is its addressing. Okay. So first thing we'll start with addressing. Okay. See, there are two types of addresses. Addresses are of two types. Physical address, or also called as MAC address. This is the address assigned by manufacturer or vendor on every network interface card or interface. Okay, it's a vendor assigned address. Okay, this address is written in hexadecimal. It's a built-in address as on every NIC card. Okay, NIC card will look like this. Every interface has an NIC card. See, this is your NIC card. Okay, see, we plug here the cable. Behind that, we have a NIC card. So every NIC card, every interface, you can say, has a built-in address called physical address or MAC address. Okay, it is represented in hexadecimal, and I'll show you how it looks like on my PC. Okay, this is your MAC address or physical address. You can see it has numbers and alphabets also. Hexadecimal means numbers as well as numbers from 0 to 9 and alphabet from A to F. Okay, so this is the address, first address, physical address or MAC address. Okay, assigned by vendor on every NIC card, every interface of a router, switch, or any device, and it is represented in hexadecimal. And this is used on LAN for communication. Used by on LAN by switches or routers on LAN for communication. Whenever two devices communicate on LAN, this is the address used for forwarding your data. Like suppose this PC want to talk to this PC. Okay, the packet is forwarded with the help of that address called MAC address. Okay, more of this we'll see when we start switching. There are a lot of details in it. We are going to discuss that. Okay, the other type of address is logical address. Okay, logical addresses, they has two categories: IPv4 and IPv6. Okay, these addresses are assigned by administrator. It's not a built-in address. As an administrator, you have to assign this address. Okay, so we'll start with logical address, IPv4. See, there are three number systems before I move ahead, which are used in our networking world. Base 2, binary. Binary means zeros and ones. This is the system language. Then we have base 10, decimal numbers, 0 to 9. The other one is base 16, hexadecimal. Okay, hexadecimal contains numbers as well as alphabets from A to F. Okay, so let us discuss some points about IPv4 addressing. So IPv4 address is a 32-bit logical address. Okay. This address is divided into 4 groups called octets. Means it's a 4 octets address. Each octet is separated by a dot. So your format of IP4 address will be like this: 8 bits dot 8 bits dot 8 bits dot 8 bits. This is the format of IP4 address. Okay, IP4 address is a 32-bit address, logical address, divided into 4 groups called octet. Each octet is separated by a dot. Okay, and then it is written in or represented in decimal number. Okay, then each octet can be assigned a numeric value from 0 to 55. Okay, you can give any number from 0 to 55. Example, I'll show you one address. This is an example of an IPv4 address. You can see 4 numbers. Okay, the range is anything from 0 to 55 is allowed. Okay. Reason 255 is maximum is 8 bits. If you look at 8 bits, okay, every bit has a value. The first bit is 1, then the second bit is 2, the third bit is 4, 8, 16, 32, 64, and 128. These are the 8 bits. Okay, it's in powers of 2, 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube, and so on. So these are the total 8 bits. Every octet has 8 bits. And what are the possibilities? If you are using a number 0, 0 in binary is written like this. This is 0. In binary, this is your decimal, and this is the equivalent of 0 in binary, 8 zeros. 1, how do you write 1? In binary, 1 is written like this. In place of 1, it will be here 1. Like that, 2. 2 means 0, 0, 0. Okay, so wherever there is a 1, you have to add that value. Okay, see here we have 1. This is 2, sorry. 3. Okay, 2 plus 1, 3. Like that, if all the bits, for example, let's say 100. How do you write 100? 64 plus 32, 96. This is 100. Okay, if you add the ones, 64, 32, 4, it will be 100. Okay, there's one more technique. For example, again I write 100. See, using the technique 100. If 100 is less than this value, whatever number you are using, like 100 I'm using, if 100 is less than this, you have to put 0. Sorry, 100, this number is, yeah, if 100 is less than this, you have to put 0. If 100 is more than this value, like 100 is greater than 64, you have to put 1 here. Then what remains? 36. 100 minus 64 is 36. If 36 is greater than 32, you have to put 1 here. So what is the remainder? 4 remains. 4 is less than 16, 0. 8 is less than 16, 0. 4 is equal to 4, put 1. Okay, this is how you get the numbers. Or you can add 1, 1, 1, you get it. Okay, like that, if all the bits are 1, okay, the sum of these bits will be 255. Okay, the sum of all these bits, 128 plus 64, 192, 224, 240, 248, 252, 254, 255. Okay, means every octet can have a range from 0 to 55. Okay, you can give any value 0 to 55. Okay, so this is the syntax of your IPv4 address. First octet, second octet, third octet, and fourth octet. Okay, allowed values are 0 to 55, including 0 and 55. Okay, is this clear? Any questions as of now on IPv4 addressing?
No, Ishak, all good.
Others? You can use chat also. Yes, no, repeat. Okay, I will repeat.
Ishak, it's okay. Yeah.
Right.
No doubt, Ishak.
Right.
No doubts.
Okay. Right. So this is the format of IPv4 address. We'll verify one of the address and take this address. Look here. This is a valid address. You look at the first number 192 is within the range. Then it is followed by a dot. Then another number within the range, followed by a dot. Another number within that range again, dot and number. Okay, this is a valid address because all the 4 octets are valid. Okay, I'll show an example here. Let us configure one address on this PC. Okay, on packet tracer, click on the device on which you want to configure address. Just click here. Desktop, click on desktop, and here you have IP config. Click here, and you can use address here. Like I am giving, for example, 100.1.2.3. Okay, you can see this is a valid address. If I type a wrong address, it will give an error. For example, I'm giving an address 1.2.3.256. 256 is not allowed. Okay, you can see if you give a wrong address, the system will not accept. Any system, any router, PC, laptop, any device on which you can configure address, if you assign any wrong address, it is not going to accept. Okay, the problem here is the fourth octet is 256. Okay, so it is not a valid address. The system will give an error. Okay, so the allowed values are 0 to 255. Okay, then more into addressing. See, IP4 addresses belongs to an organization called ICNA. This is the organization that owns the IP4 addressing, IP4 as well as IPv6 process. Okay, there is a related organization of ICNN called IANA. Okay, they carries out the policies of assigning addresses. Okay, IANA allocates the address, assigns the address to RIRs, regional internet registries. Okay, see, these are the regional internet registries. Okay, IANA give addresses in bulk to these registries. It is based upon continents. Okay, for North America, we have ARIN. All the ISPs, all the companies, they get address from their RIR called ARIN. Okay, we have LACNIC for South America, AFRICNIC for Africa, RIPE NCC for Europe and Gulf. For Asia Pacific, we have APNIC. Okay, so IANA use addresses to RIRs. From RIRs, it goes to national internet registries or local internet registries. Like India, in India we have BSNL or Airtel or Jio, okay, or ISPs. From there to the end user. Okay, so the end user can be a company, an organization, a company, or a home user. Okay, this is the hierarchy. This is how the addresses are distributed. ISN owns the address. IANA carries out the policies of assigning and allocating addresses. Okay, addresses are given to RIRs, regional internet registries. From there, it goes to national internet registries and then end users. Okay, If you take an address from an ISP or your national internet registry or local internet registry, they are called provider dependent addresses. Okay, some big companies take the address directly from RIR. Okay, they are called provider independent addresses. Okay, so there are two categories. Provider dependent means you are taking the address from ISPs. If you are taking the address directly from RIRs, then it is called provider independent addresses. Okay, then IANA, the responsible body, what they did, IANA created or grouped IPv4 addresses into 5 classes. Okay, so IANA created 5 classes. Each class has 2 portions, 2 parts. One is network part, other one is host part. Means how many networks are there in each class and what are the number of hosts present in each network. How many hosts are present in each network and the number of networks in each class. Okay, so every class is made up of 2 things: number of networks and number of hosts in each network. Okay, so IANA created 5 such classes. Class A, class B, class C, class D, and class E. These are the 5 classes that are created by IANA. The first octet will decide which class your address belongs to. Okay, first octet. If your address is starting from 0 to 127, means it is a class A address. Okay, if an address starts from anything from 0 to 127, it is a class A address. Class B is from 128 to 191. If you see an address starting from 128 to 191, it's a class B address. Class C is 192 to 223. Okay, we have class D from 224 to 239, and finally we have class E 240 to 255. Okay, so the first octet will tell you which class your address belongs to. Okay, if your address is within this range, it is class A, class B, class C, D, and E. Class E is reserved, not assigned to anybody. Okay, it's used for research and development, or they call it future use, but as of now not given to anybody. So this entire class is not in use. Class D is used for special purpose of communication called multicasting. Okay, these are multicast addresses assigned to a group, not to its individual device. Group addresses. Okay, and remaining A, B, C are the addresses which are assigned to the end devices as well as network devices. They are unicast addresses. Okay, is this clear?
Oh, yes. Yes, Ishak.
Right.
Yes, Ishak.
Right. Before I come back to I4, we'll just look at the type of transmission that are allowed in IP4 networks. Types. See, there are 3 types of communication allowed in IP4 networks. Unicast. Unicast means one-to-one. One sender, one receiver. We have broadcast. One to all. And we have last multicast. Multicast can be one to many, many to many, many to one. A group address. Okay, I'll show an example here. of these three types of communication. Okay, in IP network, the host can communicate in one of the three different ways: unicast, broadcast, and multicast. Okay, this is unicast. The process of sending a packet means the data which you are sending from one host to an individual host is called unicast communication. Like here you can see we have 4 devices connected to a network, and one of them is sending to one particular device 253. 4.1 is sending to 253. Okay, others will not receive. So this is called unicast communication. Then we have broadcast, the process of sending a packet from one host to all hosts in the network. One sender received by everybody, that is called broadcast, one to all. And the third type is multicast. So you can see here we have two groups, green group and yellow group. There is a sender, red, okay. It is sending some data towards a particular group. Only members from that group can receive. Okay. The process of sending a packet from one host to a selected group of hosts, possibly in different networks, okay, is multicast. Okay, one to group, like WhatsApp group. Suppose you send some data, some message to a WhatsApp group, only members from that group can receive. Okay, that is multicast. Even our Zoom meeting which we are doing right now is also a multicast application. Okay, those who join only can receive. Okay. Now coming back to our IP4 addressing. Okay, this is first octet which decides our class. As we discussed, our IP4 address has 4 octets. Every class has 2 portions, network and host. So class A, first octet or 8 bits are reserved for network, and the other 3 octets are host. Okay, total 4 octet, 32 bits. 8 bits are network bits, and remaining 24 bits are host bits in class A. Okay, in class B, 16 network bits and 16 host bits. In class C, we have 24 network bits and 8 host bits. Okay, class A, 8 network bits and 24 host bits. That gives us 128 networks in class A. There are 128 networks in class A, 0 to 127. Okay, in each network, you'll get 16,777,216. So class A is for very large network. Okay, 2 to the power of 20. Here we have bits. Okay, in class A we have 8 bits. 128 means 2 to the power of 7 is 128. 2 to the power of 24 is number of hosts, which is 16 million. Okay, let me explain how we got 128 in class A. See, class A starts from 0 to 127. If you convert this into binary, 0 means the first bit value is 128, right? Let me copy this one. If you convert any class A address into binary, you can notice the first bit value is always going to be 0 because the value is 128. Okay, so the first bit value in class A will always be 0. This is called, this first bit is called, first 3 bits they are called most significant bits or leading bits or high order bits, which you are going to learn in your networking world, these terms, high order bits. Okay, so in class A is equal to 0. First bit is 0. Okay, then how many combinations are left in network quotient? 7, right? 7 bits are remaining. So 2 to the power of 7 is equal to 128. See, 0 means 0, 0, 0, all zeros. Like that, you have 1, 2, 3 up to 127. You have different combinations. Okay, 127 will be all ones. So there are total 128 addresses, right? 0 to 127, 128 networks. Okay. If you want to understand from bits perspective, there are 7 bits which are not common. So 2 to the power 7 is equal to 128. Okay. If you take 2 to the power of 7, okay, 2 into 2, 4, into 2, 8, into 2, 16, 32, 64, 128. This is how you got 128. Okay, so there are total 128 networks in class A. Okay, and then host 2 to the power of 24, 2 to 2, 24 times gives you this many addresses. So a class A network will have 16 million addresses. You can add 16 million devices in class A network. So here class, you can see, defines the size of the network. Okay, class A is very huge networks. Usually these classes are assigned to ISPs, RIR, not only ISPs, RIRs will get this address, this okay, these classes, class A, class B. Okay, because the size 16 million means only ISPs or RIRs many addresses. Okay, see, every address has one more portion. You can see if you look at an address, IP4 address, it has two parts. The first part is the address itself, this one, and the second part defines the class in decimal. Okay, this is your actual address of the interface. Okay, and this is the class to which it belongs. Okay, so class A, this is called subnet mask. Class A has a default subnet mask of 255,000. So how we got 255? 8 network bits. See here, I forgot to mention here one information. Network bits are represented by 1 and host bits are represented by 0. Okay, so there are 8 network bits. So if you take an first octet here, if you write your subnet mask in your 8 bits in binary, okay, so total will be 55, and then your host bits 000. Okay, so this is called subnet mask. Okay, this is called, so every address has a portion, the address itself, and the next one is the subnet mask. So class A address, any class A address from 0 to 127 carries a default subnet mask of 255.0.0. Okay, and it is represented called prefix length by /8. Means 8 network bits. Prefix length is nothing but the number of network bits /8. Okay, let me show you an example practically here. I'll take a class A address. Okay, class A 0 to 127, 1, 2, 3, 4, for example. See here, automatically the system has taken the subnet mask as 255,000. Okay, my question is, how does the system knows that this is class A? Any idea, anyone? See, when we type the address, automatically it has given the subnet mask.
Because the first octet
Yeah.
is between 0 to 127.
No. See, system understand binary language, right? We are, as a human, we are reading decimal. Okay, what system does, the number which we put there 1, it convert it into binary. Okay, so binary 1 will be like this, right? So it looks at the first octet only, first bit, leading bit. If the value is 0 means it is class A only. Okay, see, as a human we are able to read the number, but system will not read this as 1. It will convert this 1 into binary 0001, right? Because as I told earlier, class A always first bit, it's called leading bit, is 0. Any class A address, take it, because class A is from 0 to 127, so first bit is always going to be 0. So the moment you put the number, it knows that it is a class A, because it converts this into binary.
Ishak, just one thing. Sorry to interfere here.
Yes.
You know, my actually teacher, daughter's teacher, phone came and she's asking to come to the school and just bring the students back. I mean, my daughter back.
Okay.
So I need to drop and I will be reviewing the video. And in case I come back, I mean, within
We will do
15-20
one thing.
minutes, and I will
See,
rejoin. Huh?
we do one thing. If you want to stop, we can stop today, because today's first day. Okay. I'll just finish few more.
No, I
here.
think you can continue because the
Okay.
recording will
Right.
remain available to us, na?
Yes, yes, it will be there.
So
No problem.
Ishak. I think you for the interest of other people, I think you should continue,
Okay.
and I will be expecting that you will be sharing the
Yeah,
link
after the
of the
class.
recording
After the
after
class,
the
I will
class,
finish.
and then I will be reviewing it. And in case some
No
issues,
problem.
I will discuss it in the WhatsApp group. Huh?
No problem. You can,
Thank you, Ishak. I'm
well,
leaving as of now. Huh?
no
Thank you.
problem. Right. See here, class A means the first bit is always going to be 0. Okay, when we type the number here, the system converts that number into binary, and because the first bit is 0, it knows it is class A, so it has given the subnet mask. Okay, so look here, one more thing. If you look at the address 1.2.3.4, there is a slash value, right? /8. Okay, this is the representation. /8 means class A. Okay, can you see on the screen /8 under IP address?
Yes.
I have not printed it, right? It has come by default. So class A/8. Okay, so any address you can write on class A, like I'll give 120. Okay, second, third, fourth octet can be any number. The first octet should be from 0 to 127, and the moment I print enter, you can see it has taken the subnet mask 55. So what it does, it convert this into binary. 120 means first bit is going to be 0. Okay, this is how the system knows about the subnet mask. So class A comes with a default subnet mask of 55.000. Okay, any address from class A you write, okay, the subnet mask is going to be 55.000, right? Then class B. In class B, there are 16 bits. I'll write -1 here because one bit is common. So we have 7 combinations. 2 to the power of 7 is equal to 128. Okay. In class B, there are 2 common bits. Okay. So total 14 network combinations are left. Okay. In host portion, you have 16 host bits. Okay. So total number of networks in class A is 2 to the power of 14. 2 to the power of 14 gives you this many networks. In class B, there are more than 16,000 networks. In each network, you get an 65,535 addresses. Okay, so class B is less than class A in size. Okay, so it will be given to medium-sized companies. Okay, this is for large companies. This is for medium-sized companies. Okay, and the subnet mask it carries is because /16 network bits represented by 16. Okay, this is class B. Any address starting with 128 to 191 is class B. In class B, there are total 16 network bits. 2 bits are common. I'll show how it is common. Let me take you here. Class B. So class B starts from 128 to 191. Okay, if you convert this into binary, okay, any class B address, the first bit is going to be 1. 128 means 1 0 0 0 0 0 0 0. 191 will be 1 0 160 176 184 188 190 191. So if you notice here, any class B address you can type here. The first 2 bits will be 10 because if you add this, it will be 192. 192 is class B. Okay, so class B has a value of 10. Most significant bits or leading bits is 10. 2 bits are common. Okay, then what are the uncommon bits? These 6 bits plus second octet is also network portion. Okay, so total there are 14 bits which are not common. 2 bits are common for every network in class B. Remaining 14 bits can be different. So 2 to the power 14 gives us total 16,384 networks class B. Okay, how? Let me explain you. See, n same means same network. If n is same means they are in same network. Example 128.0.0.0. Okay, what is the n part here? The first 2 octet is network. This is one network. Okay, this network is represented by 16, and you get here 65,000 addresses in this network. 128.1 is a different network. Remember, they are not same because n value is different. If n is same, means they are same network. Okay, 128.0 is a separate network, 128.1 is a different network. Like that, we have 128.2, 128.3, and so on till 128.255, because 255 is the maximum value allowed. So like that, we have 256 networks starting with 128, 129, 130. So all up to 191. Okay, till 191, we have class B networks, 191, 1, 191, 2, like that up to 191, 255. So total number of networks, that's why we have 16,000. Okay, so every number you can see has 56. Okay, 128, 256 networks, 129, 256 networks, like that up to 191, we have 256 networks. So if you multiply 120 to 63 means 91 means 63 into 256. Okay, it will give you around this many networks, and in each network you'll get 65,000 addresses. Means 128.0.0 will have 65,000 addresses, 128.1 will have 65,000 addresses. Like that, every network in class B will get 65,000 separate addresses. Okay, is this clear?
Yes, Ishan.
Okay. Everyone clear? See, addressing is very important. If you're not clear, I'm going to repeat. Okay, if you go a little slow, also no issues in the beginning, because addressing is the only thing which is you okay, which is the beginning. If you know addressing, then you can start testing. Otherwise, okay, because this is a practical subject, okay, we have to do a lot of labs. Okay, so understanding addressing is very important for troubleshooting also. Okay, if any doubts, please let me know. Okay, I'll repeat. Okay, and anyway, you can go through the recording also. If you are not clear, you can repeat also. Okay, so class B, remember, has two network portions and two host portions. Okay, two network octet, two host octets. There are two common bits. So total number of combinations are 14. 2 to the power 14 gives you 16,384 class B networks. In each network, we get 65,000 IP addresses. 2 to the power of 16 is 65,000. So class B comes with a default subnet mask of 55.55.00, and it is represented by /16. Okay, let me show you here one example of class B. 128, for example, 001. See here, what the system does, it took the first octet, converted into binary to know the subnet mask. Because the binary value will be 10, first 2 bits, it knows it is class B, so automatically class B address is S, subnet mask S. Okay, class A 255.0.0.0, class B 55.55.0.0. Okay, and if you look at the representation, you can see here /16. Class B is represented by /16. Okay, then comes class C. In class C, we have 24 network bits. 3 bits are common. Okay, that gives us 21 network bits, 21 combinations. There are 8 host bits. Okay, so we have total number of networks. Okay, more than 2 million networks are available in class C. Okay, and in each network you get 256 addresses. Class C is for small networks. Okay, every network in class C, there are more than 2 million networks. Each of these 2 million networks gives you 256 IP addresses. Okay, and class C has a default subnet mask of 255.255.250, and it is represented by /24. Okay, 24 means these 3 octet, 88824 network bits. Okay, let us see these 3 common bits. Class C starts from 190 2 to 223. Class C is from 192 to 223. 192 means 1, 1, remaining zeros. Okay. 223 means the last number 1. So you can see here in any class C address from 192 to 223, the first 3 octet value will be 110. These are called leading bits or most significant bits 110. Okay, class C is 110, and then we have remaining. So class C 3 octets are reserved for network. 3 plus, okay, 3 are common, so 5 are not, so 5 are uncommon. So 5 plus 8, 13, 13 plus 8, 21 network bits. Okay, total there are 21 network bits in class C. Okay, so 2 to the power of 21 gives you more than 2 million addresses in class networks in class C. Each network gives you 256. 2 to the power of 8 is 256. Okay, I'll write an example here. We'll see one example. Class C 192.0.0.1. Look here. Okay, it has taken a subnet mask of 55, 55, 55, 0. Okay, and if you look at the representation, it is /24. Okay, is this clear? So this is your addressing part. We have still to discuss more. Okay. Class A 0 to 127 is class A. 8 network bits, 24 host bits. 7 1 bit is common. We call leading bit. I'll write here leading bit A is equal to 0. This is called most significant bits or leading bit. Class B 10 and C 110. Okay. Total 7 combinations. 2 to the power of 7 is equal to 128. So there are 128 networks in class A. Each network gives you 16 million addresses. Class A has a default subnet mask of 255.0.0 and its prefix length or representation is /8. Okay, and class A leading bit is most significant bit or leading bit is 0. Okay, then we have class B 128 to 191 is class B. There are 2 network portions and 2 host portions. Number of networks in class network bits are 14. Okay, 14 common. There are 16 bits. 2 bits are common, that gives us 14 possible combinations. 2 to the power 14 gives you more than 16,384 networks in class B. Each of these networks gives you 65,535 addresses. Okay, class B has a default subnet mask of 255.255.0.0 and its prefix length is /16. Then comes class C. Class C is 192 to 223. There are 3 network portions and 1 host portion. Total number of network bits are 24. 3 common bits. Use the 21 combinations. 2 to the power of 21 gives you more than 2 billion networks. And each of these network gives you 256 IP addresses. And every class C address has a default subnet mask of 255.255.255.0 and they are represented by /24. Okay, and class D is reserved for multicast. We are going to see its usage when we start dynamic routing. Okay, and E is also reserved. Okay, so this is about the class. Okay, so we have 5 classes. Every class has 2 portions: network portion and host portion. Okay, network means the number of networks in each class and the number of hosts in each network. Okay, so these are the 5 classes of IP4 addressing. Any questions, anyone? Any questions or doubts?
No, Ishak, all good.
Okay. Others also, Sai, Sri, Raksha.
No questions.
Okay. So you want me to continue today, or shall we stop today and continue from tomorrow? What do you say? I'll be sharing the books, everything today, along with this recording. If you want me to continue, we'll go further, or we can start from tomorrow. What do you say?
Yeah, anything is okay, Ishak. Maybe if you send the materials, we'll have a look at it and
Okay.
be prepared also.
Oh,
That
yeah,
should
okay.
also
Right.
go.
Good. Because being the first class and Abhishek is also not there, so let us stop today. Tomorrow we can stretch up to 12:30. Okay. It will be
Sure.
2 hour classes. Okay. Right. So I'll share the recordings and also the study material and also the images required for practical. Okay. You'll
Okay.
receive it after the class. Okay. So tomorrow we'll start 10:30. Okay. We'll continue 10:30. Okay. Go through the recordings. If you have any doubt, we can discuss tomorrow when we start the class. Okay.
Sure. Okay.
Yeah. Thank you, everyone.
Thank you.
Thank you.
Ishak.
Thank you.
Thank you, sir.